Simplifying rational functions. Since a rational expression represents the operation of division, and division by 0 is undefined, a rational expression is not defined when the denominator is 0. So 1 divided by 0 can't have it. Definition: a value of a variable that makes the denominator of a rational expression equal to 0 is a non-permissible value. So if I have 1 over x minus 2, then x can't be 2, because that would give us a 0 in the denominator. It's a restriction of the variable. We'll get more into that in a bit. Let's review first what simplifying rational numbers was like when we first learned how to do it. 24 over 40. Do you remember how you learned to reduce that? What you would have done was you would have first written it out as factors, the factors of 24 over the factors of 30. So we're going to do that, but we want to write down factors that they have in common. So something that we could both divide both by. So if I write 24 is 6 times 4 and 30 is 6 times 5, and then I cancel out the 6's, I end up with 4 over 5, which is my answer. That is the exact same process we're going to use today, except we have variables now, but we're still going to be following that process of creating factors. So 14 over 35, let's try it again. 14 over 35, how could I write that with factors that would cancel out? Well, 14 is 7 times 2, and 35 is 7 times 5. So if I'm going to cancel out the 7's, I will end up with an answer of 2 over 5. So that's the process we're going to follow. We are canceling out the common factors in each number, numerator and denominator. So let's apply that skill now to rational expressions. We're getting into some variables here. Here are our 3 steps, so I'm going to go over the 3 here in a minute. Notice step 1 is factoring, which is kind of like what we just did with those numbers. We kind of factored them. And then we'll go over these next 3. Canceling comes at the end. So first, simplify and state restrictions on the variable. We have 6x squared z over 2x. Let's talk first about the restriction. So our denominator can't be 0. So this part right here cannot equal 0. So all I'm going to do is just take that little kind of equation that I made up, 2x cannot equal 0, and I'm going to isolate x, and that gives me x cannot equal 0. Doesn't matter that I'm dividing by 2. So my restriction is, I'll put it up here in black, my restriction is x cannot equal 0. Anytime you have a monomial denominator like this one, monomial denominator, it's always going to be just 0. You can solve it like I showed you here, but it's just going to be 0 all the time. Okay, we've got our restrictions. Now we want to simplify. So we're going to simplify by canceling, if we can, cancel anything out. But think of the way we just did the examples that I just showed you. So 6 and 2, let's look at the numbers first. That reduces, right? If I divide both of them by a 2, if I divide 6 by 2, I'm going to be left with a 3. If I divide 2 by 2, I'm going to be left with a 1. So what I have so far is 3x squared z over x. I reduced the numbers. Now I want to look at the letters. So looking at the letters, I have x squared over x. So that x in the denominator is going to cancel out with one of the two x's. That x squared means x times x. So I'm just going to cancel out the squared there. So what I'm left with here is just 3xz. I don't even have a denominator anymore. But the restriction that I got at the beginning still holds, and I have to rewrite that. X still can't be 0. Even though we don't even have a denominator, the restriction never goes away, so you have to always include it. This one's a little harder. Simplify and state restrictions on the variable. So let's look at our steps at the top. Step 1 is factor the numerator and denominator. So we didn't have to worry about that in our first example because they were monomials. So there's no factoring to be done when you have a monomial. So the numerator is a monomial. I can't factor it. It's just one term. So that's going to stay 3x. But the denominator is a binomial. So I can factor it. There's a greatest common factor of x. That leaves me with 5x minus 2 in the denominator. Step 2, determine restrictions on the variable. I've got two different parts here. So you always look in your factored form at each factor separately. My first factor right here, that's my first factor, and that's my second factor. My first factor is a monomial, so the restriction on that one is going to be x can't be 0. And I have to do restriction on the other factor. So remember what I showed you before, I'm going to rewrite that. 5x minus 2, that can't be 0 either. So if I bring the 2 over, I get 5x cannot equal 2, and I divide both sides by 5, and I get x cannot equal 2 over 5. So I have two restrictions. I'm going to rewrite them up at the top here. X cannot equal 0, and x cannot equal 2 over 5. Those are my two restrictions on the variable. So I'm going to erase all of this red work I did down here. Okay, so remember when you have a monomial, the restriction is always just 0. All right, that was step 2. We did step 2. Now we're at step 3. And step 3 is cancel out common factors from numerator and denominator. And this bottom line in step 3 is really important. You can only cancel a monomial with a monomial or a binomial with a binomial. So I can't take this x out of this 3x and cancel it with this x right here, because this is a monomial, but this is a binomial. So I can't do that. But I have a monomial right here, this x, which means I can cancel between these two. I can cancel here. Remember, just like we did over here, monomials. So I can cancel this x with this x. So let's do that. They will cancel out. They're going to cancel out. And when you cancel, you're dividing by, in this case, we're dividing them by x. We're left with a 1. We cancel out. We don't normally write that, but that's what it's not canceling out to 0. It's canceling out to 1. So what do we have left in our numerator right now? Well, we've got just a 3 times 1, so that's a 3 in the numerator. And then the denominator, we have 1 times 5x minus 2, so I'm just going to write 5x minus 2. Can we do any more canceling? No. Remember, the numerator is a monomial, and the denominator is a binomial, so you cannot cancel. So I'm just going to restate my restrictions, because they still exist. X still can't be 0, and it still can't be 2 over 5. And you could check those in your original question. You could sub in a 0 here. If you did sub in a 0, you would get 0 for the denominator. And if you subbed in 2 over 5, you would get 0 again. What is the domain of B? The one we just finished. What is a domain? So we're going to tie this into chapter 1 a bit. So the domain is, because we will eventually be graphing these, x is an element of real numbers. Don't worry though, we're actually not graphing them until next year, but we're going to just talk about characteristics this year. So x is an element of real numbers such that we just state our restrictions here. X cannot equal 0 or 2/5. That's the domain. Every other x value is fair game. If I were graphing this, which I'm not, but if I were, I could sub in whatever I want for x. Just not 0 or 2/5. C. This is even harder. We've got a trinomial over a trinomial. So the first step is to factor the numerator and the denominator. Okay, factor. So looking at the numerator, this is an easy trinomial. And look back to yesterday's video if you forget what that means. I'm looking for numbers that multiply to 6 and add to 5. So what does that? I'm thinking 6 and 1 or 2 and 3. Sorry, that's 2 and 3. What's going to multiply to 6 and add to 5? Well, if I wanted to use 6 and 1, that would have to be 6 minus 1. 6 minus 1 gives me 5, but 6 times negative 1, if I multiply these two together, I get negative 6, but I'm supposed to get a positive 6. So these two options aren't good. So I'm looking at my 2, 3. Oops, purple. So 2 and 3 are the two numbers for the numerator. So it's an easy trinomial, which means I can jump right to my brackets, p plus 2, p plus 3. And again, if you forget what I'm doing here, you need to go back and watch the previous lesson on factoring. Now let's look at the denominator. We're looking for numbers that multiply to negative 8 and add to negative 2. So what does that? Well, it's going to be some kind of combination of a 4 and a 2. But they need to add to a -2 and multiply to -8, so I'm going to have a -4 and a +2. So because this is an easy trinomial, those numbers go right into the brackets. P minus 4, P plus 2. So there's step 1, factor. So you need to memorize these steps. Factor, restrictions, cancel. Let me just circle those words because those are the big words there. If you just remember factor, restrictions, cancel, then you'll know your 3 steps. Restrictions. What can P not equal? Restrictions are only on the denominator. It's okay to have a numerator of 0, right? I can have 0 over 20 if I want to. That's equal to 0, and that's fine. But I can't have it the other way around. So the restrictions are only on the denominator. What can P not equal? Well, what does this factor give me? What would make that piece equal to 0 when P is 4? So P can't be 4. What about this piece here? -2. So those are my restrictions. P can't be 4 and P can't be -2. That's step 2. Step 3 is to cancel. Cancel out common factors from the numerator and the denominator. And remember, we can only cancel, all we have here are binomials. Everything that's listed here are binomials. So I can only cancel them if they match exactly. They have to match exactly. For example, I can't take this P plus 3 and this P plus 2 and just kind of cancel out the P's or something, or subtract the 3 and the 2. No, it has to be exactly the same. Do I have any factors that are exactly the same here? I do. P plus 2 and P plus 2 match exactly. So that's like saying P plus 2 over P plus 2. That's going to equal 1, no matter what P is. P could be 5 million. It's going to be 5 million plus 2. On the top and the bottom, it's going to be 1. So we can cancel out that entire factor because they're both together equal to 1. That leaves us with a numerator of P plus 3 over a denominator of P minus 4. And sometimes people get trigger happy here and they want to cancel out the P's, which is wrong. Those P's are part of a binomial, and as I've said several times, binomials must match exactly in order for them to cancel. And for me to make more sense for that, let's say P is 1. Okay, then we would have 1 plus 3 over 1 minus 4. If P is 1, that's going to give us 4 over -3. That doesn't cancel out to anything. So they go together. The P plus 3, it's a binomial, it goes together. The denominator goes together. So you have to leave it like that. You can't cancel out pieces of a binomial. So there's our answer, and we always restate the restrictions, even if some of them have disappeared. And we put the restrictions in order, low to high. So I have to actually write the -2 first and then the 4. Example 2, simplify. So even if the instructions don't tell you to state restrictions, you have to. It's part of the question. And if you don't, if you omit it, you do lose marks for that. So you always state restrictions. And if you forget and you get to the end, then you just do it at the end. So it's no big deal if you just realize later. Okay, what was our step 1? Do you remember? Factor. The numerator is already factored. This is all done. Everything's in brackets. It's all factored. What about the denominator? It can be factored as a difference of squares. Again, you can review that with yesterday's lesson if you need to. That's m, my pen's giving me a hard time here. M minus 1, M plus 1, difference of squares. That's step 1, factor. Step 2 is state restrictions. What can M not be? M cannot equal, what would it be for here? A 1, and for this bracket, a -1. So those are our restrictions. Factor, state restriction, step 3 is cancel. Does anything cancel? Well, officially we have 2 M minus 1 brackets there. They're just not both written out, but there's 2 of them there. So we can cancel this one out with one of these. So I'm just going to cross the 2 off and leave 1 sitting there. And I know it's tempting to cancel that M plus 1 with the M minus 1. They are binomials and they do not match. They won't cancel. So we're left with 2 times m minus 1 over m plus 1. And still, in order, our restrictions, -1 comes first and then +1. You might see the answer in the back like this, distributed to m minus 2, m plus 1. So that's just, and the same restrictions, that's just from distributing. It doesn't, at this point, it doesn't matter. It will later. We will have to simplify later, but right now you can leave it in factored form. Part B. Step 1, you remember step 1? Factor. The numerator has a greatest common factor. It is a 4x. When I factor that out, I'm left with 3x minus 2 over. Now, any common factoring in the denominator there? Nope, nothing comes out, so I'm going to leave that 2 minus 3x. Step 1 is factor. Step 2 is restrictions. What's the restriction on the denominator? And if that's kind of hard for me to do in my head, all I have to do is this, right? I know that 2 minus 3x cannot equal 0. So I'm just going to solve this little equation and bring the 3x over. I get 2 cannot equal 3x. Divide both sides by 3. And there's my restriction. So I have, let's put it up here, x cannot equal 2/3. There's my only restriction. So your steps were number 1, factor. Number 2, state restrictions. And number 3, cancel. Well, we've got in the numerator, we've got a monomial, that's the 4x. And we have no other monomials, just that one. This is binomial because they go together. You can put brackets around them if you want to help you see that it's a binomial and you don't think it's a monomial and want to cancel this 4 with this 2 or something crazy like that. These two go together, right? If x turns out to be 12, well then I have to do 3 times 12, negative plus 2. It goes together. Okay, up here, these are really similar, right? These binomials are very, very similar. So we can I'm going to rewrite that in a way that shows you how similar they are. So 4x is in the numerator and 3x minus 2 also in the numerator. Now if I rearrange these, that would put the -3x first and the +2 second. So I have to keep the signs with the terms. That 2 is a positive, that 3x is a negative. It looks really, really similar. I'm going to do one more thing here to show you they almost are the same. I'm going to factor out a -1 out of that denominator, and I'm left with now, so I'm dividing by negative, I'm left with 3x minus 2. So now they're the same. I can cancel this factor with this factor and they turn into 1s, and I'm left with 4x over -1, but we bring the negative up and just write -4x, and still x cannot equal 2/3. So there is an example that shows you how to rearrange a binomial to make it match when it's so similar like that. Last one, well, for example 2. We've got a trinomial over a trinomial, but that last one's kind of out of order, so I'm going to start by rearranging that numerator because we have to have the descending powers in order to do our factoring. And the denominator, I'll just rewrite that. 3x squared plus 4x plus 1. So step 1 is to factor. I'm looking at my first numerator, or my top, the only numerator. I'm looking for numbers that multiply to -6 and also add or subtract to 1. So what do you think that's going to be? Could it be a 2 and a 3? Well, we need it to add to a 1, so it's going to have to be -2 and a 3, and that will multiply to 6. This is decomposition though. So I'm going to have to do decomposition. Now, decomposition or factoring in general was a grade 10 skill. You don't have to show me all your work for it. You could jump to the answer here. But on the side, it might be helpful if you work it out. 2x squared plus x plus 3. Then you can do your decomposition here. So the factoring, remember I told you if you have a negative and positive, put the negative first. Plus 3x plus 3, then we can throw some brackets up here. Take out a greatest common factor of a -2x. That leaves me with just an x plus 1, and take out a 3. x plus 1. And my next line is my answer, so I'm going to go ahead and put that in my numerator. My numerator is x plus 1, that was the common part, and then negative 2x plus 3. Over. I want you to do the denominator yourself. Press pause right here, do the denominator. When you come back, I will have the answer for you. So there we go, and if you need to look at the work in the yellow there, you can follow what I did. So factor, done. Step 2, state restrictions. What are the restrictions? What's the restriction on this bracket right here? That's going to be x cannot equal negative 1. And the restriction here, so you can solve it the way I showed you how to solve it. You should be getting x cannot equal, for that one, negative 1/3. Can we cancel? Can we cancel? Yeah. We've got x plus 1. Exactly, binomial matches exactly here. The other two binomials don't match at all. So my answer is going to be negative 2x plus 3 over 3x plus 1. And my restrictions, again, are x cannot equal in low to high, negative 1, negative 1/3. I've mentioned it before, but if you're watching a video and you see a mistake in it, please message me so I can go back and fix it. So there we go. Good practice of factoring. If you are stuck on your factoring, then you need to go back and do a previous example. Terminology. Since a rational function, I'm just going to remember rational means one term over another term, right? Rational function, like 1/2 is a rational number, 2/3 is a rational number. A rational function just means that we have variables. Since a rational function is written like a fraction, and ratios are also written as fractions, so we write 5 to 4 as 5 over 4. That should be straight up and down, one over the other. We can say that a rational function is a ratio as well, and we can also use the word quotient. So I'm pointing that out because of the terminology that you'll see sometimes in your homework. Here's an example. The quotient of two polynomials is 5x plus 1. Create an equivalent rational expression to this polynomial that has a restriction x cannot equal negative 2. Oh, what's going on there? There's a lot of stuff. So what we have here, quotient means the answer of division, right? So this line is actually giving us the final answer. So I'm going to write this kind of at the bottom because we're going to reverse engineer this one here. So we've got 5x plus 1. This is the quotient. And it has the restriction x cannot equal negative 2. What we have to do is create a rational expression that would have given us this answer. Well, first of all, if we have the restriction x cannot equal negative 2, that means that must have been in the denominator originally. So we must have had a denominator of x, what, plus 2 or minus 2? Plus 2. That must have been in the denominator if we have this restriction, but it's no longer there in our answer. This is the answer, and there's no denominator there, so that means it must have canceled out. So I'm going to have an exactly matching binomial in the numerator because they would have canceled out there and there to get to this answer right here, which leaves us with the only thing that can be left in the numerator, which must be the 5x plus 1. So that is an equivalent expression. Get rid of those canceling. That is an equivalent expression, and that's part of the title of this entire unit is equivalent rational expressions. This is equivalent to this with this restriction. It's kind of working backwards because they gave us the answer, so we work our way backwards. A simplified rational expression is defined, so this is simplified. This was a rational expression, and here it is simplified. It's defined only for values of the variables for which the original expression was defined. So even though this just looks like a line, a y equals mx plus b thing, x still can't be negative 2. That's why you have to state restrictions before you cancel. So not a question like this because we did it backwards, but on a regular question, if you cancel and then state the restrictions on what's left, you will be missing some restrictions. So it's really important you understand that you state your restrictions before you cancel. So that lesson, kind of a challenging lesson there. I would encourage you, of course, to watch it again, because the second time through is always way better and it makes a ton more sense than the first time through. So if you want to try it again, please do. But that's it for now, and you can practice solving rationals in your homework.